Okay, this one. You can see the screen now.
Yes, sir.
Just try this one. Here, there is an x square here, and there is a product of tan x sin x. Okay, so try to get this into sin theta by theta, tan theta by theta kind of format. You have this product, no, tan x sin x, and you have product of x and sin x. So x
Yes.
square, ideally you should adjust it that way.
Ah,
So these trigonometry limits are actually easy. Just need to get them into sin theta by theta or tan theta by theta kind of form.
sir.
These trigonometry limits are actually easy. Just need to get them into sin theta by theta format.
Huh.
And you told me that you wanted to some questions, no? Some
Yeah,
questions.
yes, sir. For match plan, actually.
Okay, okay,
I'll send later.
okay, cool, cool. Which book is it? Disha, na?
Disha, sir. Yes.
Okay, okay. Your physics class is done. Physics, chemistry is done today, or they're still left.
Sir.
Physics and chemistry are done, no? Or you have this after this.
After this physics, sir.
After this is physics. Okay, okay, cool. Cool. Just break this. A minus nx. Break just complete the multiplication and see whether you can do in sin theta by theta, tan theta by theta kind of thing.
Sir, n plus 1, n plus n 1 by n.
N plus 1 by n. Very good. Which is option D, no? This one
Yes,
only,
sir.
no? Okay, what did you do?
Um, First, a minus n into nx minus tan x by x
N into nx minus tan x by x.
by
Okay.
x into sin n nx by x.
Sin nx by x. Very good. This you can make it and
Now,
then done. Okay.
simplify this. A minus n x by x minus tan x by x.
A minus n You've still broken this, right? Minus tan x by
Yes,
x.
sir.
Right, this no, this and this will get cancelled, right?
Sir, this
Right, this tan x by x, this is equal to 1 and this is equal to
1
n, no?
and sin x. Yes, sir.
And this is,
This
what
will
is
be
this one?
a minus n. Uh, e- this will be equal to 0, sir.
This is a n minus n square. What exactly is this?
A minus n in minus n.
A minus n now. Minus 1, no, this is.
No, sir. A minus n into n square minus n. Because sin n x by x. No, sir.
Okay, wait. So wait. So this is this one. Okay. This into n, no? Right. A minus n into n minus 1 whole times n. Na?
Sir,
So you got n plus n by 1 by n, no?
this will be yes, sir. This will be 0, sir. And a minus n into n minus
Yes.
1 into
This
n.
this should be 0. Agreed. So
So from on simplifying, a equal to
a equal to n plus 1 by n, right? Okay, very good. So,
yes, sir.
okay, good. You have done this before. You have done similar thing before, no? Or not?
No, sir. This is the first.
Okay, but this is easy only. Okay, I will get you one more. This is also similar. This thing, some light trigonometric manipulation. Okay, just try this one. You have tan 2 theta and cot 2 theta. Just try a little bit of trigonometric manipulation here also. By the way, sine theta by theta graph, no?
Yes, sir.
It looks like this. Okay. That's why when theta tends to 0, it is approaching 1 from both the sides. When theta tends to infinity, it approaches 0, right? Because the numerator
Yes,
is
sir.
always between plus 1 and minus 1, and denominator is increasing. That's why this is actually equal to 0, right? What about x sine 1 by
Yes,
x?
sir.
X sine 1
Sir,
by x. X sine 1 by x.
reverse of this.
Reverse of this. So what is the limit?
Limit uh, infinity, yes, extends to
H
1 by
sine.
x tends to 0.
So net what is that? Okay, first you do this problem.
1
We'll
s-
discuss that also. First you do this problem. Then you are able to break this.
Yes, sir. 1 minute.
Hmm.
Sir, ఒకసారి చేస్తారు.
Okay, okay. So, what is x tan 2x? We'll write it as x into 2 tan x by
1 minus tan square x.
1 minus tan square x, right?
Yes, sir.
1 minus tan square x. Right, minus 2x tan x, this let it be. Okay, this is actually 2x tan x, okay? 2x tan
Yes,
x.
sir.
And then what is cos 2x in terms
2
of
sin
density?
square x.
1 minus cos 2x is
2 sin square x.
2 sin square x, very good.
Whole
2,
square.
2 sin square x whole square. Okay, now we have 2x tan x here, 2x tan x here. Okay, so
Tan
this
x
becomes,
common.
no, we'll take 2x tan x only, directly common.
Okay, okay, okay. Yes, sir.
2x tan x times 1 by 1 minus, sorry, 1 by 1 minus tan square x,
Minus 1.
tan square x minus 1. Okay, very good. And what is the denominator? Denominator is 4
4
sin
sin power 4x.
4 sin power 4x. Okay, the numerator becomes 2x tan x into 1 minus 1 plus tan square x, right?
Plus
So
tan square x.
that is tan square x by 1 minus tan square x, right? Whole of this by 4 sin power 4x. Agreed?
Yes, sir.
Okay, so what will this become? This become numerator 2x tan cube x, right?
Yes, sir. By 1
Okay,
minus.
by 2 by this 4 sin power 4x into,
సార్ ఇది ఇలా రాసుకో 2 tan x by 1 minus tan square x into x tan square x అని రాసుకో అప్పుడు సింప్లిఫై అయిపోతుంది.
it doesn't matter whichever way you write.
ఓకే.
Okay, so let's see this one 1 minus tan square x, right? So we have tan cube, we have sin power 4, and we have 1x, right? So, and what is this? This is limit extends to 0, right? We are not so concerned about this now. Okay, limit extends to 0, tan cube x by this x cube into x cube we can do, right? And we have 2x here. This x and this x cube will make it 4 sine power 4x, right? This x you can bring it here, right? This also becomes x power 4. right? Into 1 minus tan square x. Agreed?
Yes, sir.
Okay, so what does that mean?
X power
We'll be left
4
with,
by
with
4 sin
this.
x
This is one. This is one, right?
1.
And what will be left? This is this is half, no? 2 by
2 by
4.
1 minus 2 by 1 minus tan square x.
2 half into 1 minus tan square is anyway 0. X is 0, right? Which is equal to half,
Yes, sir.
right? So half is the
Okay.
answer.
Yes,
Understood? I
yes,
think
sir.
you have done
Yes.
this only somewhere. You have done some calculation mistake. You have done this thing
Yes,
only,
sir.
no? Where exactly went wrong? You did
అంటే నేను
you got
sin power 4x I multiplied and divided by x power 4, sir. So there it went wrong.
no. Then also you should get no. See, sine power 4, x power 4. You have got right.
Uh,
Where you went wrong? You did exactly the same thing. See, tan square x. You don't need to worry. 1 minus tan square x. Rest
oh,
all
okay. Yes, sir.
okay. So and we need to adjust the remaining things only. There is tan cube here, sine power 4 here, and anyway, see this 1 plus 3 4, and the sine power 4 is anyway 4. So we have enough x's.
Yes, sir.
Okay. I think you know. Oh, okay. Now let's get back to our original question. What is x sine 1 by x? What about this? This is a very important
The
question, by the
limit,
way. Limit.
x sin 1 by x, there's no limit, sir.
There is no limit when x tends to 0 or x tends to infinity. So that is the first question. So this is very
Infinity, sir.
important for your conceptual understanding. When x tends to
Infinity
0,
one.
when x tends to infinity. When x
Mm,
what you are answering? Okay, okay. Let's try arguing both the logics. Okay, x tends to infinity and x tends to 0. Okay, when x tends
yes,
to
sir.
0, what you are saying? Is it infinity again?
When x tends 0, 0.
Okay, and then limit is 0. Okay, equals to 0. What about x tends to infinity?
1 by x will be 0,
1 by x will be 0.
and x will be infinite.
So 0 into infinite.
No, sir. Then it will be 0 and then
It is 0 only. Okay, okay. So, okay, I'll give another logic then. Tell me which one is right. 1 by x, 1 by x tends to 0, right?
yes,
Okay.
sir.
Okay, when theta is very small, sine theta is equal to theta, right?
Oh, yes, sir.
Then 1 by x, sine 1 by x should be equal to 1 by x. This is my logic. Okay. Sine 1 by x because 1 by x is very small. So x into 1 by x should be equal to 1. I'm giving another argument. Okay, you have given one argument which is 0. Okay, and someone might give argument of infinity. I'm giving a third argument which is equal to 1.
Okay, sir.
Okay. So what exactly is the limit? Okay, I'll give another fourth argument. Okay. This is nothing but sine 1 by x by 1 by x. Okay, now call 1 by x as some theta. Then this is nothing but sine theta by theta when limit theta tends to 0. Right? This is this only, no? Agreed.
Yes, sir.
When x tends to infinity is nothing but when theta tends to 0. So limit sine theta by theta, this should be equal to 1.
Yes, sir.
Agreed. So that's why it is important to understand how these ones look graphically. Okay.
Yes, sir.
Okay, I'll show you this one also. How does it look? It looks like this. Okay, it's actually, you can see the picture, no? It's actually equal to 1. The limit is actually equal to 1. Okay, what the both logics that I told you, right? Both are right. Where is this logic? This sine 1 by x by 1 by x. This is very clear, right? So this is a very plain logic,
Understood.
right? Right. So this one, when theta tends to 0, sine theta by theta is equal to 1. That means x sine 1 by x is equal to 1. Okay. When x tends to infinity. And when x tends to 0, x sine 1 by x, this actually tends to 0. But what is the proof? What is the argument here? The argument is the sandwich theorem. Okay. How do we use sandwich theorem? What does sandwich theorem say? If one function is lying between two functions, right? And we know these two functions they converge at this point. Obviously, this function should also converge at this point, whether we know the limit of this or not, right? Okay.
Yes, sir.
Now x sine 1 by x. X sine 1 by x, sine 1 by x, whatever you do, this is always between minus 1 and plus 1, right? So x sine 1 by x should always be lesser than x, right?
Yes, sir.
So it will always be lying between this line and this line, right? Okay, so whatever you do, this x, this line x and this line x, this line minus x, whatever, they are going towards 0, right? So x and 1 by x obviously will lie between this, whatever oscillation it can do, but it will still always lying between this. If we call this f of x, we call it g of x, and the middle one if we call it h of x, the limit of f of x and limit of g of x is actually equal to 0. So limit of h of x is also 0. Agreed? We don't, it doesn't need to exist at this 0. It can be a whole. That is still fine. But the upper this upper function and lower function, right? These are always greater than or equal to this x and 1 by x, right? This is basically the sandwich theorem. Agreed?
Yes, sir.
Okay, understood, no? Okay, we will discuss this again in more detail. The continuity of these functions, the differentiability of these functions. Okay, this x sine 1 by x, x squared sine 1 by x, these all things are very important. Just read these also. In our Sange's book, you might have this. Just read about these functions. These are important. Okay.
Okay,
What
sir.
about this? Okay, so and it is not so straightforward. Okay, so what about differentiability of this? Okay, then what about differentiability of x square sine 1 by x? Is it differentiable at x equal to 0? Okay, these are important questions. Okay, ma?
Yes, sir.
O- Okay, just check in your textbook. Okay, then we will discuss this at a later point of time. Okay, we'll
Okay, sir.
quickly check. We'll quickly do another question. This is actually a simple one only. Again, some trigonometric variation. X and 1 by x, at least the limit you are clear no now.
Yes, sir.
When x tends to infinity or x tends to 0.
Yes, sir.
Okay, good, good. Try this one. Simple trigonometric manipulation only. You should not do basic errors.
Root 2, sir.
Root 2. How? What did you do?
Sir?
What did you do? Hello. What did you do?
Sir, x tends to 1, sir. So x minus 1 also tends to 0.
Yes, x minus 1 tends to 0. Very good. Then, so x minus
Then
1 is
1
theta,
minus
theta
cos
tends
2x will be 2 sine square x by 2.
2 sine square
2
x
sine
by
square
2.
x.
X 2 sine square theta by 2, right?
Yes, sir. Here
Two,
cos 2x, 2 sine square x.
this
Root
is,
2 sine x by x 1. Sorry, root 2.
sorry, 2 sine square theta by 2. Okay. Now what? Root 2
No,
sine
sir.
theta.
Here 1 minus cos 2 of x minus 1, sir. So it will be 2
So,
sine square x.
root 2 sine theta, right? Sine theta by theta. Right. So you are
Then sine
saying,
theta by theta is 1.
okay, okay. Now, okay. So when we do limit of sine theta by theta, okay, we are just looked at the graph. Okay. This limit of sine theta by theta, this theta can be positive, theta can be negative. Similarly, sine theta can be positive, sine theta can be negative also. So for example, at this side,
Yes.
theta is also negative, sine theta is also negative. That's why the ratio is coming out to be positive. Right. Now here, what you are doing, you are restricting sine theta to be positive.